Welcome everyone, I'm Sergi Garcia and I'm a PhD student from the Computer Vision Center in Barcelona. I'm going to present my paper called Step Towards Structured Text Spotting. First, I'm going to explain the motivation behind our work. One of the problems we encounter with the generic OCR systems for syntax is that they detect the text at arbitrary granularities, which is usually at word level. This can be a problem if the text we want to read contains spaces. We usually have to couple these systems with post-processing operations. Another problem is that generic pipelines are usually biased towards in-vocabulary words, which are the set of words that the model has seen during training. When the model sees a word it has never seen, it has more probabilities to misspell it. And finally, they can mix letters and numbers if they are visually similar. For example, they can mix the number 1 with the letter L. Instead, we propose an alternative framework to spot text if it has a known structure. Our approach makes use of the known record expression of the text to guide both the detection and the recognition process. The advantage of our approach is that it avoids detection fragmentations and it reduces spelling mistakes. So, in order to do this, we have created a new training and validation dataset, which is based on the higher text dataset. The reason behind using this dataset is because it contains information at different hierarchical levels. It contains paragraph, line, and word level information, although we don't use the paragraph level information. We make use of this information to create new instances which contains spaced text. And the strategy we follow is to merge adjacent words into new instances. We both merge the location and the caption into a single new word, and both captions are separated by space. The structured text spotter, or STEP for short, is the model we use to tackle this problem. This architecture is based on TSTR, which is a generic syntax spotting network, which uses transformers. In our architecture, we use the regex of the text we want to read to bias both the encoder and the decoders of the network. That includes the localization and the reading of the text. Biasing the network this way avoids detection fragmentations and reduces spelling mistakes. We have compared our model with different generic OCR systems, which we use as our baselines to compare our model. We couple these OCR systems with post-processing operations, mainly to deal with spaced text. Both in the validation dataset and the test dataset, our model displays better performance in all the cases. Qualitatively, we can see that our model effectively removes the problem of text fragmentation. In the example on the left, we don't separate the different terms of the text into different bounding boxes. We also prevent mixing numbers and letters in the example in the middle between the letter I and the number 1. And finally, we also avoid reading the text with the wrong structure. In case of a phone number, we have read the correct number of numbers. So, in conclusion, we have introduced the structured text spotting task, a new task in the field of computer vision. We have also introduced a new test dataset, which includes different classes of structured text. Each one of these classes has a different record expression. And we have also introduced a step, our own approach to tackle this problem. And we also have shown that they effectively improve the spotting performance of structured text. Thank you for your attention.